In this video, we're going to talk about a special application of rational equations called the work problem. We need to think of rates or speeds in a different fashion than we're used to. We're used to saying if I go 200 miles in 4 hours, I would just take 200 divided by 4, and I know that my average rate of speed is 50 miles per hour. But we can apply that to other situations. John can paint a whole house in 14 hours. Therefore, his rate or his speed of painting is considered 1/14th per hour. If the pool takes 6 hours to fill, then the rate of the pool filling is at 1/6th of a pool per hour. So these are all rates just like miles per hour. So let's take a look at these again. John can paint a whole house in 14 hours. Therefore, his rate of speed is 1/14th of a house per hour. But if John painted the house for 6 hours, how much of the house has he painted? So we take his rate times his time. So in his case, we take 6 hours times 1/14th, and we know that in 6 hours he's painted 3/7 of the house. Okay, let's look at the other example. The pool took 6 hours to fill, so its rate of filling was 1/6th of a pool per hour. So if it's been filling for 3 hours, how much of the pool is filled up? Again, we just simply take the rate times the amount of time it's been going, and 1/6 times 3 gives us half, or 1/2 of the pool is filled. Let's take a look at this problem. A sink has 2 faucets, one for hot water, one for cold water. The sink can be filled by a cold water faucet in 3.5 minutes. If both faucets are open, the sink is filled in 2.1 minutes. How long does it take to fill the sink with just the hot water faucet open? So we can see that the rate of the cold water faucet flow is 1/3.5 sinks per minute. And we can go ahead and leave that in decimal form for what we're working on. Now, the flow for both faucets together is 1/2.1 sinks per minute. Now, for the general formula we're going to work with is you take the rate of the one faucet by itself to fill one sink, plus the rate of the other faucet by itself to fill one sink, equals the rate of both faucets to fill one sink. So in our case, we're going to set up as this. 1/3.5 plus 1/x, because we don't know how much for that faucet, equals 1/2.1. So at this point, it's a matter of solving our rational equation. So I'm going to start by doing the common denominator. And I can see that my common denominator will be made up of 3.5 times 2.1 times x. Now I'm not going to multiply them all through, and I'll show you why here in a second. So what I'm going to do is look at each denominator. So I need to multiply the first term, 1/3.5, by 3.5, 2.1, and x. Well, the 3.5s are going to cancel out, and all I'm going to be left with is multiplying this numerator by 2.1 times x. Now, if I take the second fraction, I'm going to multiply it by 3.5 times 2.1 times x. Well, the x's are going to cancel, and I'm going to be left with multiplying by 3.5 times 2.1. On the right side, my denominator is 2.1, so that will cancel with the 2.1 in my LCD up here in the corner. So I know that I'm going to be left with multiplying by 3.5 times x. So now that we've used our LCD to clear our denominators, let's see what we have left. First term, I have 2.1x times 1 plus 3.5 times 2.1. So let's go ahead and multiply that out and get 7.35. And the term on the right side, we're going to have 3.5 times x times 1. So now I have a basic equation, no fractions left. I'm going to go ahead and simplify. By putting the 2.1 over to the right, those cancel. I have 7.35 equals 1.4x. Of course, we need to divide by 1.4 on both sides to get x by itself. And we get that x comes out to be 5.25. Once we've rounded, it does come out where you're going to have to round the answer. So that means that it took 5.25 minutes to fill the sink with just the one faucet.